that window. Okay, so as another concept here, I want to talk about, I don't know this, how can I get rid of this? Okay, the domain. So the domain and range of a function. Of course, this is a little bit advanced lesson, so I just want you to understand what the notion of domain and range is for a function. Actually, the domain of a function is the set of all inputs that the function can accept from you, the function accepts from you. If you put all those elements in one set, that set is called the domain of your function. But of course, in your lesson, we are always talking about functions of numbers. So I would say that the domain is a set of numbers that your function can accept from you. For example, if I talk about this function, f of x equals to a very simple function, x plus 2. So it is clear that this function can accept any number except even real, even imaginary numbers. But for this lesson, even if some of you knows about the complex number, forget about that. So I'm talking about real numbers. So there is no restriction for the values that I can put instead of x for this function. Yes, it doesn't matter which value I choose for x. This operation is always doable. Yes, so it means that there is no limitation for this value for x. So I would say that the domain, and I write capital D for domain, and then I would a subscript f, the name of my function. So the domain of this function is the set of all real numbers. So there is no limitation for the numbers that I can put inside instead of x for this function.
Baba,
but for example, yes?
How is this different from the first lesson?
Not that much, but I want to go through this a little bit more explicitly.
Okay.
I have another question.
Yes?
Why do you write IR for all real numbers? Because you wrote IN for
no
all
IR.
natural numbers. So what does the I mean?
No, there is no IR. This is a standard notation for the set of real numbers. So
yeah, but wait, it has I in common with the notation for.
That is
Is
not
it not?
I. No, it's not. Just it's a line next to it. I cannot write it handwriting, but this is. I need to probably show that to you. I don't know if I can show it here.
Hey, Babak.
Really annoying, yes?
Could you read my name out loud?
What do you mean?
Read my Zoom name out loud.
No, I cannot see the Zoom window. Don't distract me right now with those things. What do you mean that?
Okay. Next time, don't worry.
Yeah. Because I don't see the Zoom window. This is why I ask you to talk to me if you have any questions. Let me, if I can show you. So you see here, this is the way that you write R, this one. Do you see my screen?
Yes.
Yes.
Yes. So this is the I am supposed to write, but of course writing something is a little bit hard. People also write something like this, but this is not I. This is not I. The reason that they put it here because the set of real numbers are so important in mathematics, so we want to have a unique symbol for them. If I just simply write R, it might be confused, for example, with the radius of a circle or whatever. But if you see this symbol everywhere in mathematics means the set of real numbers, okay?
Okay.
So if you are confused, this is not IR, this is just R. For example, the set of integers, instead of normally writing it Z, you write something like this. So this means that this is not just any Z, it is the set of integers. And then the set of natural numbers, you just don't write it like N, you just put a line next to it. So this is the set of the natural numbers. There is no I, okay? Is that clear?
So how important is it? How important is it that we know these symbols for the exam? Do we need to like write these symbols in the answer?
No, it's better. For example, if I ask you what is the domain of this function, the best way to answer this is just to write df is equal to r.
So yeah, that's so what we should write in the exam then.
Yeah, if I ask you the domain of this function, then you need to answer exactly what I have written here. Yes, df is equal to r.
Yes.
Okay. And now let me just give you another example. You might say that, okay, what is the good point about, what is the strange thing here? Because some functions have some limitations. Let me just give you the simplest possible example, and that is 1 over x. If I ask you what is the domain of this function, the domain of this function is not the set of all real numbers. There is a limitation of the values that you can choose for x here. And that case is that x cannot be equal to 0 because otherwise the denominator is 0 and this is not defined. So what I can say is that this is the way that you need to learn how to write. That's also important grammatically. So you need to write the domain of my function. So D for domain, little g as a subscript for the name of my function. So you can say that you need to remember how to write. You need to open a curly bracket and then say that what you want to put in. You want to put every number except one number, and that is 0. So then you would say the domain of the function is you need to read it in this way. This is called the set. And then you write something like this, x belongs to, and then you put the symbol for the real numbers. So let me read it so far. Domain of G is equal to the set of all x's belonging to the real numbers. And then you put a vertical line. This vertical line means such that. And then you put your condition. Your condition is that x is not allowed to be 0. And then you close the curly bracket. So this is the domain of the function. I don't want you to get confused. This is the literature. This is the grammar or punctuation rule, how to write. But the idea is very simple. If I ask you what is the domain of this function, I am asking you about all possible values, the set of all possible values that you can choose for x. Then if you want to answer this orally to me, you would say that I can choose every number that I like except 0. Instead of saying this English sentence, you can just write this in symbols. But when you want to write it in symbols, mathematics is a language, so you need to respect the punctuation rules and the grammar rules for that language. So for example, here you are not allowed to put, you cannot say why I'm not allowed to put brackets. The reason is that at the end of the sentence, we put full stop, we don't put comma. That's the same reason. Okay, so this is the domain of this function. So the operations that have some limitations, let us review them. So we have some operations that we learn about. So this is the sum, the summation, addition actually, sorry. Addition, subtraction, multiplication, division, and then taking some roots, yes? Okay, so we have, for example, powers. We want to raise some number to some powers, and then we can take square roots, the third roots, etc., etc. So powers and roots. Okay. For this one and this one and this one, we do not have any limitations at all. What does it mean? It means that as soon as you give me two numbers, I don't even care about the values. I can always add them. I can always subtract them. I can always multiply them without any limitations. But for these operations, we can have some limitations. For division, there is only one limitation. If I want to divide A by B, there is one restriction that I need to respect for this operation, and that is the second one cannot be equal to 0. The first one can be in 0, no problem. But the one on the right-hand side, if you want to write it as a fraction, it means that the denominator cannot be equal to 0. So division, or this fraction line equivalently, have some restrictions. You are not allowed to put a 0 for the second number. Powers, or if you remember, we also talked about powers. There is one sort of power which is not defined. And of course, in some books and some mathematicians, there's some disagreement, but at least the calculators respects that. So if you write 0 to power 0, this is also undefined. So if you want to have this power, a to power n, this is more or less defined everywhere. So of course, this is, if this is a natural number, this is always defined unless we have 0 to power 0. There are some limitations, of course, here. If I ask you, what do you remember that we had a formula? Let me talk about the nth root. If I have the nth root, if you remember from previous lessons, if n is odd, there is no limitation of what you can put here. You always get an answer. But if n is even, then you need to be careful. You cannot put any number that you like here. Do you remember what was the rule? If, for example, if I can I say the fourth root of -6? If I am working with real numbers that we are, this is not defined. Because if you remembered some previous lessons we had together, if I have an even root, I am not allowed to put a negative number below it. So you need to know these limitations. And for example, is this defined? -6 to power 1/4. If you remember, we also talked about this. This number to power 1/4 is actually another name for this one. So this is also not defined. You see, these are not defined. So we have some limitations when it comes to roots and powers. So you need to be careful about them. But of course, these questions could be in principle hard, and I will just design some of these questions and upload them in the playlist. I will show the playlist today to you here. So if you are interested to solve more harder problems, you can go to that playlist and try to solve those problems. Okay, now let us do some more exercises here. So let me clean this. We don't need any more here. So I can give you another function, h of x, and then let me write it as 5x minus 2 divided by 3x plus 2. I'm asking you, what is the domain of this function? Okay, so you see that there are some operations going on. For example, between these two, I have a multiplication. Then between these two, I have subtraction. Again, here, multiplication, addition, and then I also have division. But multiplication doesn't have any restrictions. Subtraction doesn't have. Addition doesn't have. So the only operation that I need to be careful about is this division. This means that the denominator should not be equal to 0. As far as the denominator is not equal to 0, I am on the safe side. I can put any number for x that I like to. The only probable limitation is that the number that makes the denominator equal to 0. This I cannot put. If you can do it in your head, so what is the number that makes the denominator equal to 0? You can just do it. But systematically, if the problem becomes harder, we need to systematically solve this question. It means that I need to ask myself what that value of x is such that this becomes 0. Because if this becomes 0, this means that I am in trouble. But this is a simple problem now, because you know how to solve this problem. You take -2 to the right-hand side, then you divide by 3, then you get 2/3, -2/3. So it means that if I choose this number, then the denominator becomes 0 and I will be in trouble. And this is the only one that makes trouble for me, because I solved this equation and I just found one answer. So if I ask you what is the domain of this function, in the exam, you have to write this calculation in principle. And then you say that, okay, now I want to make this defined, so I need to exclude this bad number for this function, bad in quotation marks, yes? So then I need to write the set of all real numbers such that x is not equal to this bad number for this function. So that is the domain of this function. This is the way that you have to write it. Okay? I can give you another example. Let me take, for example, k of x. I can write 1 over x, and then I can write plus 3 over, I don't know, for example, 5 minus x. So what is the domain of this function? So this, I want you to understand only this one. When I ask you what is the domain of this function, I am asking you to give me the set of all numbers that I can replace x with those numbers. That is what I am asking you. Okay? And then the way that you need to think is about the limitations that you have for operations. And at the level of the book, you only face with simple examples like this, but you can make a complicated function and try to ask yourself, what's the domain of that function? As I told you, I will give you some of these examples in that playlist. If you are interested, you can watch the videos. But now, can you roughly say there are how many numbers that are not useful for this function or good for this function? What are the limitations for the values of x that I can choose?
All real numbers.
0 and 5.
0 and 5, there are 2 of them. Yes, because I have 2 division operations, and I need to be careful about division operations. Yes, so it means that for this division, because for the whole function to make sense, all pieces of the function should make sense. Otherwise, the function as a whole doesn't make sense at all. So for this one to make sense, the denominator shouldn't be equal to 0. For this one, the denominator shouldn't be equal to 0. So it means that, but here the problem that this is very simple. You really don't need to solve it. You can just guess it. So then you can write that the domain of k is the set of all values in R, but such that, first of all, I need to have the first one make sense. So it means that x shouldn't be equal to 0. This condition guarantees that this part is defined, but there is no guarantee that this is defined. For this one to be defined, 5 shouldn't be equal to x. So it means that and x is not equal to 5. Okay, and then sometimes I told you that there is a symbol for and, you can use this symbol, yes? So instead of this one, not on top, exactly instead of and, you can use this one. So there are 2 limitations here in this function. X equal to is not equal to 0, not equal to 5. There's also another type of examples at the level of the book. So let me give another function, L of x. For example, let me just tell that square root of 1 minus 2x. So here I want to find the domain of this function. So how should I find the domain of this function? There are operations. Let us investigate the operations. I have a product here, no limitations. I have a subtraction here, no limitations. But then I have a square root operation. There is some limitation for this we need to know. Okay, so what is the limitation? I am not allowed to put a negative number below the square root sign. So it means that if this function is supposed to be defined, the under square root sign shouldn't be negative, or it should be non-negative. Sorry, it shouldn't be negative. So it means that this number should be positive, or minimally it can be equal to 0, but not less. Okay, and then if you remember your previous lesson, what is this called? Do you remember? If I want to find the values for x from this, what do you remember? What was the name of this lesson?
You mean inequality?
An inequality.
Exactly. Yeah, that's an inequality. So it means that I have to solve the inequality. To solve the inequality, I hope that you remember, I have to keep minus 2x here and I move on to the right, so it becomes minus 1. Then I divide by minus 2, but because minus 2 is a negative number, this is the only point about inequalities. So when I divide or multiply by a negative number, I have to interchange the sign, change the direction of this sign. And then the left-hand side becomes simply x, the right-hand side becomes 1 over 2, and the sign is less than or equal to. But usually, I don't know, in the book, they write something like this, but this is not quite right because the domain is a set and you need to respect the way that I told you, okay? So this becomes domain of L is the set of x's in the real number, but not all of them, such that this number x is less than or equal to 1 over 2. So let me just again ask you, what is the meaning of what you write? This is important to know what's the meaning of what you write. It tells you that if I choose x any number is smaller than or equal to 1 over 2, and I choose that number and put it here, this will make sense. Otherwise, this does not make sense. For example, if you want to test, let us choose x equal to 0, and let me choose x equal to, for example, 1. This does not belong to my domain. This belongs to my domain. This symbol means belongs to domain. This does not belong to domain. Yes. Okay, but let us check. Can I ask you to calculate f of 0? You would say yes. You are only allowed to calculate f on those numbers which belong to the domain. And 0 belongs to the domain. How do you know that? There are two conditions. One, the condition is that it should be a real number. Of course, 0 is a real number. There is another condition for the domain. The number should be smaller or equal to 2, and that is 1 over 2, and that is correct. So this is in the domain. Let me calculate this. You need to know how to calculate this. You need to replace x with 0. So it becomes 2 times 0. Then it becomes square root of 1 minus 0. Then it becomes square root of 1, which becomes 1. So you see, I get an answer out of it. But clearly, if I ask you what is f of 1, you immediately realize this is not sensible because this number does not belong to the domain in the first place. How should I know that? Because the numbers that are smaller than or equal to 1/2 are allowed to be in my domain, but I realize that 1 is not fulfilling that condition, so 1 does not belong to my domain. If you don't believe, you can calculate. If you start calculating, then it becomes 1 minus 2 times 1, but then it becomes 1 minus 2, then it becomes square root of minus 1, which if I am working in the domain of, in the set of real numbers, this is not defined. So it means that if I go to the complex numbers, it is still defined. So if I am working with the only real numbers, this is not in the domain, but if I go to the complex numbers, if I make my set a little bit bigger, then of course, this is also in my domain. But let me just keep it in mind that we always work with real numbers at this level. So it's not defined. So, and that was predictable because immediately I realized that this is not in my domain. So that is the concept of the domain. Yes. Let me make it a little bit more challenging to see what do you think about this problem now. So for example, let me write s of x, and let me write this square root of x plus 2 square root of, let me make it 4th root of 1 minus x. What do you think the domain of this function is? Let us analyze the problem. Yes, The only thing is that you need to make sure that every operation that is going on in the function is sensible and is defined. You need to guarantee all of them. So how many operations you see? I have a second root going on here. I have a subtraction going on here. After subtraction, I am taking the fourth root. After that, I am multiplying 2 here. And then after I found this and I found that, I am doing this addition. So you see there are a number of operations going on. But there are, so what your concern is only for 2 of them. This has a limitation. You need to be careful about this. And this has a limitation. You need to be careful about that. This addition, subtraction, multiplication, you really don't even need to think about them. There are no limitations for these operations. Okay. But because this function has 2 pieces, I need to consider 2 scenarios. First, I need to guarantee the existence of this part, well-definedness of this part. Because if this is not defined and this is defined, still the whole package is not defined. Okay? So I have 2 conditions. So here, let me write it. We have 2 restrictions here for this function. So number 1, let us only concentrate on this piece here. What is the condition that I have to impose for x to guarantee the existence of this part? Yeah, you can answer me.
X cannot be negative.
So how should I write it? Cannot is a negation, so let me write it properly with positive sentence. It should be greater than or equal to 0. But this doesn't guarantee probably the second one. But for the second one, what is the limitation? What should I guarantee for the second bit?
X cannot be larger than 1.
Okay, but I want you to solve it. So it means that yes, 1 minus x should be greater than or equal to 0. Again, I have an inequality. I move my 1 to the left-hand side. It becomes minus 1. Then I divide by minus 1. But I have to change the sign, yes, because I'm dividing by a negative number. Then the left-hand side becomes x, the right-hand side becomes simply 1. Okay. So let me ask you one question. Do you think that there should be an and between these 2 conditions, or there should be an or between these 2 conditions?
And.
In other words, do you want to have these 2 conditions simultaneously fulfilled, or one of them fulfilled, the other one is not, is also okay?
Be simultaneously.
Okay, when you say simultaneously, remember that there's this connection is and. Okay, and then you show it by this symbol. If you mean or, then you show it with this symbol if you want to. You can just write words, okay? So if I want to write, I would write the domain of S is equal to the set of all x's in the set of real numbers, but I have 2 limitations. X should be greater than or equal to 0 on the one hand, and x should be less than or equal to 1 on the other hand. If you stop here, that's completely okay for me, and that's actually, I would consider the hard problem at the level of your book, but that is very easy to understand what's going on. But there is a better symbol in mathematics that people use instead of writing so long. I don't know, have you seen it before? We can write x. On the one hand, it is greater than or equal to 0. And on the other hand, it is smaller than or equal to 1. So we call it x is between 0 and 1 inclusive. It means that I am including the endpoints. So I would prefer to write it in this way, but if you stop here, that's completely okay. So it becomes the set of all real numbers such that x is greater than or equal to 0 on the one hand. On the other hand, it should be less than or equal to 1. So the domain of this function is very limited. If you want to make a sense out of this function, you need to restrict yourself only with the numbers between 0 and 1. So, for example, if you draw the graph of this function, you will not receive any part of this function out of this. By the way, that's also good if I can just do this using GeoGebra here. Let me see if I can draw that function. So I would say y equals 2. If I want to draw it, there should be a square root sign here, and then I have x, and then I will go plus 2. By the way, do you see the GeoGebra? How do you think that I can put the fourth root here? I have only these limited symbols. That's also good to learn. Can you see the GeoGebra?
Isn't there like a squared symbol? I think there's like a squared symbol.
No, but I have the fourth root now. You remember, let me show you, the function is 2 times the fourth root of 1 minus x. But if I want to punch this in GeoGebra, if I go back here, I have these symbols. I have a square root, of course, separate button, but how should I write the other one?
Could you like write the expression and then to the power of 1/4?
Exactly. So, and then this this is the thing that I need to use. So let me see if I can do that. I write brackets x, 1 minus x to the power. I press this button, and then I go 1/4. So 1/4. Yes. Hopefully everything is correct. But if I press, then you see what happens. This is the graph of your function. Let me make it a little bit bigger. As we predicted, so you see the domain of the function gives you a lot of information. This function is not that easy to draw the graph. You will learn about this in calculus and in other courses. But you see that I was able to predict that this graph will not extend beyond 0 to 1. You see, this is 0, the origin, and this is 1. And you see that I was able, even though that was a hard problem, it was not even easy for me to guess that that would be the shape of the graph. But before seeing the graph itself, I was able to make sure that the graph will not extend below 0 and after 1. Because in this calculation, I realized that the domain of my function is just between 0 and 1. It means that, yes?
Why does the diagram curve?
Yes.
Yeah, in the diagram. Why does it curve?
Yeah, it is a curve diagram. Yes.
But why?
Okay. This is not an easy question. If you want to have a straight line, so first of all, why this is curved? By the way, that's also a good point to talk about. What is the meaning of the graph of a function? Can you make sense of the graph of the function? How do you think that we draw the graph of the function? For example, this is a very this is a very subtle question, how to draw the graph of the function. You need a lot of mathematics machinery, and you will start learning this prerequisites from mathematics 3C. We need the notion of derivatives and higher derivatives to be able to understand that this graph will be curved in the first place. So I cannot answer it right now. But you can have a feeling. What is the meaning of this function? If I want to do it, I need to calculate this function for different values, but values between 0 and 1. For example, let me just think about, I don't know. For example, I can take 0.4 and put this here instead of x. And then I get a number. And then I would, for example, here, if I am right, this would be around 2.4. So then it means that I go and click this point. Okay, so you see this point you see here on GeoGebra, the x coordinate is 0.4, and the number that GeoGebra immediately produced you here is the number that you will get out from this function if you put 0.4 into instead of x and calculate the number using your calculator. This would be this number. Then you turn this pixel on your display. This would be 1 point of the graph of your function. Okay, for example, let me go to another point. For example, let me click here. Then you immediately see that if I go down, the x coordinate of this point is 0.2. So I made a little bit of mistake. So let me clean it. It is not exactly 0.2. If I can exactly point here. Yes, that's better. 0.2. And then take this number and put it into this complicated formula, calculate this number. And of course, up to 2 decimal points, this number is that one. Okay, and then if you see this point, but you need to do this process not only for 2 points, but for all points between 0 and 1, which is of course practically is not possible because I have infinitely many points between 0 and 1. So even if I can do all these points, I can do it 100 times, I can do it 1,000 times, you know, but I cannot do better. But mathematics, the mathematics that you will learn next year will guarantee that if you use those kind of mathematics, it will guarantee you that the shape is qualitatively exactly this. For example, you will not find a very strange point in here. Even though I haven't checked this point between B and A, because my power is limited, how many points I want to calculate. I cannot calculate infinitely many points. But mathematics will guarantee you that there is not something like, there is not a point like this that you are missing. No, you can immediately use those rules, which are not that easy. You need to be patient and then study for 2 years so that you can see that the graph of the function would be something like this. You shouldn't expect any odd behavior in this function. So what I'm trying to say is to understand the notion of the graph of a function. Yes, please?
I had a question. So yes. In the first situation, if we put 0.4 as x, yes, we will get 2.39 as y, right?
Yes, yes. According
and is that so can we say that 2.39 is the highest number that we can get as y?
If my eyes are working properly, yes, I cannot see. Might be I can go a little bit higher by moving to the right. Did I move? No. So apparently you are right. Too, you see, when I am moving it around that point, that's actually a deep question. You see, when I am moving this point, the x coordinate is changing, but you see, that is very strange, but because that should also change. Yeah, the y coordinate should also change. I don't know. This is not that sensitive. The reason that the y coordinate doesn't change around this, it's because it is containing 2 decimal places. Okay, if I can calculate more decimal places, then you will see the changes. But you are right. If you see that this is the highest value, this is the highest height, yes, that is not possible to go beyond that. Yes, do you understand what I mean?
Yeah, thank you.
It is clear that this green curve is below this 2.4. This is completely clear, at least for my eyes. Yes, so it means that definitely the maximum height of the graph of the function is definitely lower than 2.4. But how much, I don't know. Okay, I would guess that this is the maximum. Of course, you see, it's a very good question because you cannot rely only on your eyes, because if the differences are so small, our eyes cannot detect that. But the point is that mathematics will be able to detect that. That's one reason that we study mathematics, because we want to answer 100% definite answers to definite questions. Okay, so I don't want to distract you by these things, but I just want you to know that the prediction that we did with domain was completely right. When we drew the graph of the function, we actually saw, we anticipated before drawing the graph. We were able to anticipate that the curve regarding to the function will not extend beyond this limited interval of 0 and 1. Yes, is that understandable?
Yes.
Okay, so let me see, for example. By the way, let me so for example, do you remember, let us just consider this one. You see this function. Now tell me, what is your prediction about the extension of the curve of the graph of this function by looking at the domain of the function? Can you say something about it by looking at the domain of the function? I mean,
it will
not about the
0.5, right?
May you repeat it, please? I think it was right.
It will not extend beyond 1/2.
So in other words, do you expect that this graph of this function will be on the left-hand side of 1/2 or on the right-hand side?
The left-hand side.
Of the left-hand side. Hopefully everyone agrees, yes, because you see that the domain is limited below this value, okay? Now, to remember this function, square root of 1 minus 2x. Let me go to GeoGebra, and then I don't know, how should I get rid of all these things one by one? Or I can do it. By the way, it's better to download GeoGebra. It's a free application, and it's very, very powerful. You can, this is what I have downloaded here is GeoGebra Classics 6. This is the latest version. And I think little by little, it's better to start working with that. You need to be comfortable with working with softwares that you need to use. Let me also get rid of this curve. And then
will we use GeoGebra during the test?
No, you are not allowed, because you can only bring your calculator. Okay.
But perhaps in the future.
I myself never use calculator for drawing graphs or something like that, because GeoGebra is a much nicer tool. Okay, so we can learn a lot of things, even geometry and everything with this tool. Okay, but later in Math 2C, I will focus mainly to teach you about this as well. Whenever we teach something in Math 2C, we can also do something in GeoGebra to understand the concept better. But let me try to draw the graph of this one. I need to put a square root sign. And then below this is very important. Don't write 1 minus 2x. Oh, GeoGebra is very clever. So he understands that, or it understands that I have to extend this square root sign. Okay. By the way,
is there any reason to why you use y in this graph?
Yes, that's a good question. I will come back to it, because the values that, oops, what I did, I don't know. Let me redo it again. Okay, I realized this is on the point, so I need to go to this one, move, and then let me write y equals to, I go to a square root, and then I will write 1 minus 2x. So make sure that everything is under this one. And now let me draw the graph. Oops, where is the graph? Oh, it's here. I have zoomed in a lot. You see, this is the graph of the function. So you were not able to guess this should be above the x-axis all the time, but at least you were able to predict that the graph does not extend to the right-hand side of 1/2. And I hope that you can exactly predict what that number is, yes? If you don't believe, we have to highlight that point. And then you see here, this point is exactly 0.5, which is this function, yes? We had this one here. This was 1/2. So that was exactly according to our prediction. But could you also predict that it is not below this x-axis? That is another notion I want to talk about, and that is the notion of the range. Okay? So we have a little bit of time. Oops, I lost the track of time. Okay. But let me talk a little bit about the range. The range. This is a much harder subject. And what I want you to know is to understand what the meaning of range is. But calculating the range could be quite subtle and impossible sometimes. But you need to understand what's the meaning of the range. Let me make the analogy very clear for you. So if you remember, I talked about function as the corresponding between two sets, yes? Oops, I need to go back to GeoGebra. So the numbers that the numbers that I can feed into my function, all of them, when I considered all of them, that is called the domain. But then I start applying my function, let us call it f. I apply my function on this point. It takes me to another point here. I highlight this point. I do this one for the next point. I will, for example, it takes me here. I highlight that point. I do this for this one. It will take me to another point. And I need to be patient to do this process, not only for few of them, for all of them. After every point that I have done is highlighted here, I put them in a bag, or I don't know, I put them in a collection. That collection is called the range of the function f. So you see, it's completely clear that calculating the range is much subtle. You need to do mathematics to be able to calculate the range. So this is why they don't ask calculating the range in Math 2C, in Math 1C. And actually, I haven't seen that they have done it for high school in Sweden. But the idea should be very clear for you. So when the domain is not that hard. If you consider the limitations of the operations used in your function, this is not hard. You need to be patient, even if the function is complicated. It contains more operations, but that is easy. You need to be patient, take care of all those operations one by one. Not all of them, by the way, only the ones with limitations like division and roots, okay? After that is done, then you can write your domain. Usually in the domain, there are infinitely, the functions that we are working in Math 1C, the number of elements in the domain are infinite. But technically, what is the meaning of range is to take your function, apply your function one by one. I am putting one by one in quotation mark because if there are infinitely many, the idea of one by one is vague. But you understand what I mean technically. I need to take that function. I start applying my function on each one of those points in my domain, and then I will highlight the outcomes. When all the outcomes are found, I put them in a collection, and that collection is called the range of the function. Okay? So hopefully this idea is clear somehow. So for example, let me make it very simple by a very simple example first. So if I tell you what is this simple function, let me consider this very simple function, just f of x equals to x. Everyone tell me, what is the domain of this very simple function?
All real numbers.
There's no limitation at all. That's all real numbers. Okay, now let us draw this analogy. So let me put the real numbers in this bag. For example, I just want to give you, because the calculating the range, you see that just by this method is impossible. You have to have more efficient methods. But for example, can this function act on 1? Yes?
Yes.
What is
yes.
what is the answer when it acts on 1?
1.
It is 1. Yes. Can this function act on 1/3?
Yes.
Yes.
This 1/3 is another point in my bag. How many points I have in my bag? Infinitely many. But I'm just considering some of them to get the feeling right. So then this will take me to which point?
1/3.
1/3.
1/3, thank you. Can this function act on minus square root of 5?
Yes.
Yes.
Yes. So what would be the answer?
Minus square root of 5.
Okay. You see, already you have this feeling. So first of all, there are infinitely many dots, infinitely very big number dots here. But you really don't need to go to all of them to get the feeling what is happening on the right-hand side. If I do this for all the numbers in this bag, what do you expect you will get here at the end, even though there is no end for this process?
Infinity.
No, there are infinitely many numbers, but what is that collection again?
All real
It's
numbers.
all the real numbers.
Exactly. So you see, you just solved the problem. The domain is R, the range is also R. As simple as that.
So does this mean that if you have no restrictions, the range is equal to the domain?
No.
Okay.
That's also a good question, a very good question. Let us just give you this idea. Let us explore this. Let me go to another simple function. F of x equals to x squared. Okay, tell me quickly, what is the domain? When I ask what is the domain, I am asking you if there is any limitation, highlight them for me. Is there any limitation for the number of x that you can put here?
No.
No.
It's just all the real numbers.
What is the domain?
All the
All
real
real numbers.
R. So let me draw my bag again. Oops, it becomes a circle this time. Anyway, so, and then I want to collect the idea. So let me choose number 1 here. It will give me what?
1.
1.
Let me choose square root of 2. What does this will give me?
2.
2.
It will give me 2. Okay. So far so good. It is not that easy to guess what's happening here, but I want you to convince you that I will not have all numbers on the right. Can you see why? You see, I do not have any limitation. My domain is R, but of course it is not easy, for example, to write all of them here, but I want to convince you that it is the case that some of the numbers are missing here, not all the numbers you will find here.
It's the negative numbers that are missing, right?
Exactly. The negative numbers you will not find here. For example, even if I give you a negative number, this function will act on it and will give me what?
1.
1. So this means that this is also being assigned here. By the way, is it allowed or not?
It's allowed.
It's allowed.
It is allowed. The other way around was not allowed. Do you remember? It was not allowed to have 2 points going to the same point. This diagram is not allowed. But this is allowed, so it is function. But you see, even if I put a negative 1, it doesn't take me to some number. It will take me here again. Then, do you agree that you will never find a negative number here, yes?
Yes.
Agreed.
Because the negative number here means that there is a number here that when I square it, it becomes a negative number. But you know that it doesn't matter. Even if the number is negative, when I square it, it becomes positive.
What about 0?
So 0 becomes 0. Let me write that one. So if I put 0 here, this will take me to 0.
But 0 isn't a negative number.
No, 0 is not a negative number. 0 is not negative. 0 is not positive. This is also a good question. This is why mathematicians are not actually stupid, because sometimes they talk about non-negative numbers. This is different from saying positive. This is also good to know. When we say non-negative, it means either greater than 0 strictly or 0 itself, because 0 is not positive nor negative. So when I say x is positive, this English sentence should be written in symbols like this. But when I say x is non-negative, this in mathematics is written in this form: greater than or equal to 0. So just respect this also. This is also good you asked about. So, but you see, it is not clear. I convinced you that not all of the numbers you see here, at least you are convinced that you will not see any negative number here. But can you conclude something about the range? Oops, the time is finished. But let me just finish it here. Can I conclude something about the range immediately? No, it is too soon to jump to conclude something. I want to make sure that every number else you can find it here. For example, can you tell me, is 4 in my collection?
Yes.
Which one is being assigned to 4 from the left hand side? 2. Exactly. So 4 is there. Do you think 3/5 is also here?
Yeah.
Yes.
Which number is going to 3/5 if you say so?
Isn't it the root of 3/5?
Exactly, the root of 3/5 and another one minus a square root of 3/5. Exactly. Both of them will go here. So now this is better now. I hope that this argument will convince you that, first of all, no negative number is in my new list, but all other numbers are in my list. Do you agree?
Yes.
Yes. So this means that I realized what is the range of f. The range of f is the set of all numbers R such that x is greater than or equal to 0. And usually it is common when you talk about the range, you don't use the same letter x. Okay? If you write like this, that's completely okay. But when you talk about the range, people, this is, again, you like the word, you know, I don't name it, convention. So this is why. Because later we talk about the graph of the functions a little bit more deeper. This domain is related to the x-axis and the range is related to the y-axis. This is why when we talk about the range, we use letter y, and when we talk about the domain, we use letter x. Okay, just let me finish this one because we didn't have time to come to this, but let me just
Babak, did you write the belongs to sign to y?
Yes.
Okay.
Yes, that is belong to, yes. So just let me just finalize this. This is our prediction, you see. I don't know, so let me clean this. You see, this is the graph of the function x squared that we just talked about. You see, I do not have any limitation for x. If I zoom in and zoom in and zoom in, you see, this is extending over and over from -infinity to infinity. But the negative numbers, you see all the graph is lying above the x-axis, not below. This is the range of that function. Okay, sorry for being a little bit over time. I will stop this here and then pause the video. So let me pause the video first.